First section from the unit on graphing lines, we're going to deal with slope. Most of us have a pretty good feel for slope, but let's just make sure we got it. Let's suppose we got this turtle. You're going to ride a turtle that moves 2 miles per hour. So look, here's the little turtle on this map. The house is here. We'll say that's 0. And this is 1, 2, and 3, and 4 miles to the west. And this is 1, 2, 3, 4, 5 miles to the east. The turtle is starting out 4 miles due west of the house. And this little Hummer is moving real slow, about 2 miles per hour. So after about 3 hours, it makes it 2 miles east. So what happened was, that coincides with the turtle starting here, 4 miles to the west, and it keeps moving towards the east after time goes on. So after 3 hours rather, it is 2 miles due east. So what we can do is we can say, all right, let's get the turtle back out of here. We can start at this point. This was the point 0, -4. That implied at time 0, the turtle was 4 miles to the west of the house. After a few hours, it made it up here to this point, which is the point 3 and 2. Meaning after 3 hours, the turtle had made it 2 miles to the east of the house. So what we'd like to see is we'd like to calculate the slope. Well, we know that slope is calculated by taking the change in the y over the change in the x, otherwise known as the second y coordinate minus the first y coordinate over the second x minus the first x. And most of us are comfortable with this, but let's just make sure we're fine. This was our starting point. We'll call this x sub 1, y sub 1. Those are not exponents, those are subscripts. So at time 0 in the x direction, we were -4 miles to the west in the y direction. After we got to the next point, this is x2, y2. And so our second x coordinate is 3, our second y coordinate is 2. If we follow this formula, then our slope is going to be the second y, which is that guy, the 2, minus the first y, which is the -4, divided by the second x, which is 3, minus the first x, which is 0. If we do the math on this, we get 2 minus the -4, which is 6, divided by 3 minus 0, which is 3. That gives us a slope of 2, meaning that this little bugger is moving 2 miles for every hour that goes by. Because if we recall, what we've been doing with these graphs is we're saying, let's look at what the y implies. So this is 2 miles after 1 hour. So it's change in y over change in x, and those are in miles, those are in hours. So that would be our slope. Then what we can do is we can say, well, we want a line for this, and most of us have seen y equals mx plus b, where m is the slope and b is the y-intercept. This line crosses the y-axis at -4. That's why its y-intercept is -4. It's also important to note that the y-intercept is the y-coordinate associated with 0, and so with 0 for x. So our formula is going to be our slope was 2, so it's 2 times x, and our y-intercept is -4. So there we go. This is the equation for this line mapping the turtle's travels from -4 to +2 miles in relation to this house. So what about parallel lines? Well, parallel lines have the same slope. They just start at a different place. So this line corresponded to the turtle starting 4 miles to the west, and as it traveled 2 miles an hour, it made it to 2 miles to the east of the house after 3 hours. 2 miles east of the house after 3 hours. But let's do this. What if the turtle started 1 mile to the west of the house? And then after 3 hours, it would make it 6 miles, it would make it over here. So if it started 1 mile to the west of the house, then we could bring this line over here and we could say, well, you know what, that really corresponds to that situation. It started out at time 0, 1 mile to the west of the house. So that would be that y-intercept right there. And then it keeps traveling at 2 miles per hour, so it goes up 2 miles while it goes over 1 hour, up 2 miles while it goes over 1 hour, and so on. As it goes over 1 hour, it goes up another 2 miles. So you get this line right here. Well, what if instead, oh, so by the way, that line, the first line, let's write that in red. The first line, if you recall, was y is equal to 2x minus 4. That's when the turtle started at 4 miles to the west of the house. The second line is the line y equals 2x minus 1, and they're parallel. Notice how they have the same slopes, the same rates of change. In both cases, the turtle is going 2 miles per 1 hour. So they both have a slope of 2, and if those lines are changing, if y is going up by 2 while x goes over by 1, then lines that have the same slopes are said to be parallel. If instead our little turtle started at 4 miles to the right of the house, then it's starting at a positive 4. So it's going to start right here at time 0. At time 0, 4 miles to the east. But it's still going to travel 2 miles per hour. So we're going to take this line over here, and it's also parallel to the other two lines. So this line would start at 4 miles east, but it's also going to be traveling 2 miles per hour. So if you notice any lines that have the same slopes, 2, 2, 2, they're the same rates of change. It's got the same steepness of the curve in relating y to x. Contrast that with lines that are perpendicular. Let's construct some perpendicular lines and explore how the slopes relate. Let's start at the point 1, 2. So we're going to start at the point 1, 2, and from that point right here, the point over 1 up 2, we are going to go from there, we're going to go up 3 units and to the right 4. So we're going to go up 3 units and to the right 4. 1, 2, 3, 1, 2, 3, 4. Boom, there it is. That would be a line that would start at the point 1, 2 and have a slope of 3/4. It goes up 3 in the y direction while it goes over 4. Well, let's contrast that with another line whose slope is the inverse of this and the opposite of it. So the opposite reciprocal, its slope would be -4/3. So let's again start at the point 1, 2 on the graph, but from there, let's travel along this line, a line whose slope is -4/3. So we'd start at the point 1, 2, and we would this time go down 4 units, 1, 2, 3, 4, and then to the right, I blew it, to the right 3 units. That didn't work so well. Oh, I know why. Pretend I didn't do that. Let me just erase that real quick. I forgot to do this. Let me start over. Let me grab that bad boy right there. Okay, we're going to do it now. We're going to start at the point 1, 2, and we're going to go down 4 units, 1, 2, 3, 4, and to the right 3 units, and go right there. Now, what do you notice between those two lines? Well, hopefully, you notice that those two lines form a right angle. They're perpendicular to each other. So, if you notice that two lines have slopes that are opposites of each other, a negative as opposed to a positive, and they're inverses of each other, they're reciprocals, then you know right then and there that those two lines must be perpendicular to each other, because that's the nature of how those slopes relate. So, if you were to see a line, if you wanted to find a slope of a line perpendicular to this one, then what you do is you focus on the slope. Notice I put some just ugly y-intercept over there. That's because that doesn't even matter. All you want to know is, what would the slope be for any line that was perpendicular to this one? Well, the slope of that line would be the opposite reciprocal, or the opposite inverse. So if this was negative, the slope of the perpendicular line would be positive, and its slope would be the inverse of this, so it would be 3/5. So we would say, the slope of the line perpendicular is 3/5. The line perpendicular to this one would be -5/3. Boom, there it is. Now how about this guy? What's the slope of the line perpendicular to this? Glad you asked. First we need to make the slope into a fraction. Then we can take the opposite inverse of it. The opposite of +2 is -2, and the inverse of this fraction is 1/2. So any line that would have a slope of -1/2 would be perpendicular to this one. So if we said, hey, you know what, I spy with my little eye a line that's this, -1/2 x plus 17, do we agree that this line and this line must be perpendicular to each other because their slopes are opposite inverses of one another? And then finally, if we're going to figure out what the slope is for any particular line. This is pretty simple, but what this means is this slope of 2/3, we could start at the point 1 of the y-intercept on the y-axis at 1, and we know we could find another point along this line by going up 2 and over 3. So we could go from here, we could go up 2 and over 3, boom, and that line would look like that. And from that point, we could do another up 2 and over 3, and look at that. We'd keep getting an extension of the line that's parallel to the one before. From this point, we can go up 2 and over 3, and lo and behold, we get that line, and it just goes infinitely in each direction. So that's how we can graph a line and know what it's going to look like. So that's the beginnings of this unit on graphing lines, and that's how slope relates.